and those who have been joining us from the beginning of the day, because I see a very good drop in the numbers. But then again, it's well and good. So at least we now know that means who are joining, or let's say who are interested to join, or let's say who have, you know, devoted some time to be a part of these sessions. Anyways, nevertheless, so today what we'll be doing is we shall be discussing about reservoir engineering. If I'm not wrong, then we shall be touching upon a few concepts of enhanced oil recovery, or let's say tertiary recovery, and then and if time is still there, if I'm able to manage the time, then what I shall do is I shall try to take you towards the concepts of unconventional hydrocarbons as well. So till yesterday we are done with the production practices as well, right? So like today we start with the reservoir engineering. So when it comes to reservoir engineering, so one thing I've been telling about the reservoir engineering discipline is that in a way it's the managerial discipline that the oil and gas industry is having. Because in reservoir engineering, what happens is we end up designing one model, we end up devising one model based on which flow simulations are being carried on. So what we do is in a way we forecast how the basin, or let's say how the oil field is going to behave, depending upon the varying conditions of operations that we might be implementing in the various oil and gas wells, right? And from these simulations, what we shall understand is we shall get to know, or we shall be having an idea that for how long, or what would be the various implications, or what would be the various responses to those input conditions, and how the recovery of the oil and gas might be affected. Right? So the scope of reservoir engineering means it has a wide approach. It starts, or let's say the scope of the reservoir engineering principles, it starts right from the time we discover a particular well. Then it goes all the way towards the abandonment phase. So that is why the reservoir engineering discipline, or the reservoir engineering team, is very much necessary. Let's say it's very much crucial for the oil and gas operations. Yes. Whereas if we see that we have the exploration team having its limited, investment of technical expertise, then we have the development teams, and then we have the operations team. So the operations teams can be the drilling teams, it can be the production teams. But when it comes to the reservoir engineering team, so they are there, or let's say means they are omnipresent in the oil and gas operations. Because right from the time we have one particular well that is being drilled, be it a dry well, be it a wildcat well, be it a discovery well, so from that point of time till the last well is being drilled in that particular block, or let's say in that particular field, those data will be fed into the reservoir model, and based on which the reservoir engineering group will be having a very near to appropriate picture, or let's say a scenario what is going in the subsurface. And then accordingly what they can do is they can suggest, or they can advise the productions team, or let's say the higher management, that how is the field behaving, or what is going to happen in the coming days. So that is what the simulation studies, or that is what the forecasting operations helps us to understand, right? But then again, so when it comes to reservoir engineering, so it is not as easy, or let's say it is not as simple as we speak, or as we understand now. So it tries to examine the existence, the accumulation, and the economic feasibility of the oil and gas reserves, or let's say the existence of the hydrocarbons, from a variety of angles, or let's say from a variety of approaches. One of them is we try to understand how this oil and gas has formed. Yes, how this oil and gas have migrated, and how they have accumulated. Yes, and how they might migrate further. That is one thing that we try to look into. Yes, then once that is done, then we also try to find out that how it can be produced. That means based upon the reservoir engineering, or let's say based upon the reservoir engineers intervention, only then what happens is we get to know, or we have the luxury to find out what would be a profitable drillable location. Yes, so we just can't, if suppose this is the field, or say if this is a model, you just can't simply drill wells here, right? So there has to be certain characteristics, there has to be certain criteria or parameters that has to be maintained, based on which the wells have to be drilled. Because at the end what we're looking is we are expecting profits. So profitability is the prime concern. It's only then we would be going ahead with the drilling of the wells, right? And finally, what we do is we put all those concepts, we put all those understanding, the information and the data that we're receiving into building of a particular reservoir model. So these things we have already understood. If I'm not wrong, we have already covered. Yes. So how come alongside with the sedimentation processes, or how come along with the process of sediment deposition, burial, and compaction, how come the organic materials, or how come the living organisms have undergone extinction? They have settled down at the seabed, or let's say the oceanic floor, and then how come they have transformed into a very useful component for the entire society, right? So here what happens is, as there is pressure, temperature, and then as there is time, then what happens is there are changes, or there are structural changes in the substances, or let's say in the deposits, or let's say in the organic deposits that have been going on, or that has taken place a long time back. So it all starts with the formation of kerogen. Then what happens is the kerogen, it then again it transforms into oil, and further it transforms into gas. Yes. So in this case, we're talking about the maturity. Now, when it comes to maturity, so this is the thermal maturity that we're talking about. That means as the temperature is increasing, then what's happening is the existing substance, or let's say the existing compound, or let's say the existing hydrocarbons, they are subjected towards transformation. They are subjected towards changes in its properties, right? So this is what happens. So that is why you have to keep in mind, or that is why the oil and gas society, what they do is they don't keep a particular block for a longer period of time, because there might be issues of migrations as well. There might be issues of transformation of oil into gas, and when this happens, then again it won't be of that much use, or let's say profitable for the companies, because what they're looking is they're looking for crude oil, because from the crude oil lot many substances, lot many products can be obtained. Yes. Whereas in case of natural gas, I have already told you that what happens, or what is the fate of the natural gas. So these are the various changes that the hydrocarbons, or let's say the various organic compounds undergoes when there are different changes in the pressure, temperature, and alongside depth. Yes. And then again, we should never ever forget the time, right? So we have few stages, that is the diagenesis, catagenesis, and metagenesis, which indicates the formation of kerogens, which indicates the formation of crude oil, and alongside crude oil we have the wet gases, and then at the metagenesis stage what you have is you have the dry gas zone, right? So altogether this is a complete understanding of how hydrocarbons undergo transformations, and how they eventually end up being crude oil or natural gas at the end. Now, things inside the reservoir, they are very much microscopic. So we are talking about pore scale scenarios here. So let's say if this is the sandstone, so we can't see, or you won't be able to judge whether this sandstone would be having oil or not, or whether the sandstone might be having potential hydrocarbons or not. It is only when the sandstone, or let's say when there's pieces, or when the samples are subjected under microscopic observation, it is only then we shall be observing pores, we shall be observing the minerals, or let's say the matrix. Yes. And alongside we shall be also observing the existence of fluids, if there are any. Right? So that means we are talking about a microscopic scale of existence. So that means if you see, that means we are talking about 1 barrel of crude oil, which is around like 159 liters. Yes. So in order to achieve 159 liters of crude oil, you just see, that means what is the extent we are talking about. Yeah. So that means microscopic scenarios are giving rise to some recovery of barrels of crude oil daily. Yes. Not just 1 barrel, but many million barrels. Yes. And that too on a continuous stretch. Yes. So it's a mix up of all the concepts combined. So reservoir engineers, whosoever gets to work as a reservoir engineer, so they have a very good luxury in their professions. Yes, but then again, they do have to endure, they do have a lot many technical challenges because it's a multidisciplinary concept that they have to grab in. Yes, so they have to correlate, they have to interlink each and every concept, or let's say each and every issue with one another, right? So they have to think themselves, so they have to think of the problem as a mechanical problem, they have to think of the problem as a way of geology, or let's say the geophysical, or let's say the geoscience background. They have to also understand the problems in terms of how it can affect or how it can implicate the drilling conditions as well. So the reservoir engineers, like I said, so they are the managers. Yes, so they have to maintain, they have to understand problems from all these peers. Yes, it's only then if they are able to come out with a solution, it's only then it's a benefit, it's a boon for the entire project, it's a good thing for the entire oil and gas field. And only then what will happen is we shall be able to achieve recoveries again, right? So the main objective, if you are to conclude, then what will happen is they will be dealing, or they have a few things in their mind, the reservoir engineers, I mean to say. So to produce oil and gas, or let's say to produce hydrocarbons in such a way that the economic recovery is maximized. Yes, that means recovery is going on, no doubt, but it has to be economically feasible, it has to be economic in nature, right? Then the rates at which the hydrocarbons are produced, that has to be also maximized. Yes, so that means on one hand you require a good flow rate, and on the other hand you also require a good profitability, right? So these things are hard to maintain. Yes, because either you increase the pumping rates, or let's say that means you increase the recovery rates. Yes, and then maybe you shall be getting a good revenues that is coming in, but what that will lead to is the pressure depletion might come down, right? So that means in order to achieve both the conditions simultaneously, but then again ensuring that the pressure depletion is again maintained, it is strictly, it is monitored. So that is the way how the success of the oil and gas industry is ensured. Yes, so if suppose I say that I have a particular oil field, so that means, that doesn't mean that by drilling 100 wells I shall be having a higher productivity. Yes, so no, so that is not necessary. So by drilling 50 wells also might give you the good profits. Yes, so this 100 number of wells, if you're drilling it, so maybe it will just endure some 10 years of production. But if you go ahead with the 50 wells, so definitely it shall go up to some 30 years. Yes, so all those things are being considered. Yes, so like I said, that it's a simulation, it's a forecasting mechanism that they involve. So these are all the things. What they do is they try to they try to feed into the reservoir model, and accordingly what they do is they get the outcomes. And when they simulate the flowing conditions, the simulation is not for 1 hour, the simulation is not for 1 day, or neither for 1 year. Yes, the simulation is for some, let's say 3 to 5 years on a stretch. Yes, so just imagine then, means what is the data, what is the amount of data, let's say what, how many terabytes, or let's say how many gigabytes, or let's say how many meta or zettabytes of data we're talking about here, right? And all this data, if it is properly maintained, or let's say if it is properly fed into the model, only then you shall be getting appropriate outcomes, appropriate results. Yes, because reservoir model, you might have come across this term, or let's say you shall be coming across these terms when you are entering in, or let's say when you're enrolling for those reservoir modeling and simulation subjects or classes. So it's known as a trash box, it's known as a idiot box. So what happens is, whatever we are feeding into the model, so accordingly we are getting the output. So that means if you're giving 10 barrels, right, so accordingly to this 10 barrels of input we shall be getting the output. Yes, so this model won't say that this 10 barrel, or let's say there is a minimum standard, or the information which you're entering is having some errors. It will just process whatever you're feeding it, right? So that is why the human brains are required again. Yes, because this reservoir models which you're building up, so these are not some AI based machines, neither it has not been exposed to lot many field scenarios by which it will understand, that means whether the data which has been entered or which has been fed by the user, whether that is appropriate or not. right? And alongside, while doing so, while ensuring all these conditions, that means this major condition, so what we do is we also keep a check on other things as well. That means the probable, or let's say the potential issues that might arise. That means the amount of gas and water that is produced alongside it. While, because about water we have discussed yesterday how it is irrelevant for us, the same goes with gases. Yes. Then how the wells would be placed in the entire oil field. Yes. Then when suppose you have decided on a particular number of wells, then what shall be the proper distance. Yes, because let's say there are two wells. Let's say this well was being already drilled from a very long time. Now this is the new well that is being drilled. Yes. So this well was also giving you some 500 barrels of oil per day. And now, so what you think is, in order to get more and more recovery of oil, let's say you have set a target of 800 barrels of oil per day. Yes, from these two wells. So now what will happen is, maybe altogether you shall be getting some 700 barrels of oil per day. But what will happen is, in case of this well, it has dropped down to some 100 barrels, and other 600 barrels is, or recover it is obtained from this particular well. So in this case, what will happen is, the previous well, which was, behaving, or which was giving you a good productivity, it has now dropped down drastically. Why? Because there has not been, given a good consideration about the distance between the wells. Because what we have is, we have a porous media. Yes, we have a porous media through which fluids will be passing through or seeping through to the pore spaces, to the pore networks. And finally, what they will do is, they might come across a conduit. They will be entering, or they will be interacting with a conduit, or let's say with a particular wellbore, through which those fluids might be going all the way up to the surface. Now, in order to ensure, in order to decide the potential, or let's say decide the viability of those reserves, or let's say the viability of the oil fields, what we do is, we do certain calculations, we do certain estimations. One of the most common is the hydrocarbon in place, or let's say oil or gas in place. Yes, so that means oil originally in place or oil initially in place. So this is what we're calculating, or let's say gas initially in place. Yes, and then gas originally in place. This is what we're calculating, right? So that means, in a given field, what is the initial volume of oil or gas that is present there, right? Then out of this oil initially in place, or the gas which is initially in place, what would be the recoverable reserves? Yes, that means, if suppose I say, that means if you are having some 100 barrels of oil initially in place, from this 100 barrels, how much or how many barrels of oil can be recovered? Yes, now this recovery, just mind you, so this has to be a economically viable recovery. Yes, so it has not to be it cannot be a recovery just for the namesake. Yes, so you are expecting some $1 billion from the outcome. Yes, but to achieve this $1 billion mark, what you have done is, you have already invested some $80 million. Yes, so just imagine what is the gap here now, right? So if suppose normally what would happen is, like, you invest 10 million, or let's say 10 million is, all used up, or it is invested in recovering the fluids, and you just see what would be the gap, what would be the margin. Right? So in a similar way, what we see is, from the given oil initial in place, what is the recoverable reserves, right? And once you estimate that, or once you get an idea of that, then what we do is, we come down to the specifics, that what would be the individual well production potential. That means each and every well that shall be drilled, or that is already there, what is its production potential? Yes, so out of 10 wells, how many of them are performing well? How many of them are performing below average? And how many of them are on the verge of abandonment, or let's say getting into a certain phase, or let's say they can be also transformed, they can be also modified into an injection phase. But then again, while converting or while modifying those into injection phase, one has to keep in mind that, is that injection phase or period necessary for now? That is also one thing. So that is the reason why many wells in the oil fields, they are kept in the shut-in condition for a very long time. But then again, apart from that, shut-in also helps to build up pressure. Yes, so pressure buildup is also necessary. So at times those are lot many strategies that are being played upon. So in a way you can also call it as a permutation and combination that is being implemented by the reservoir engineering team. Right? So these are all the scenarios that we are looking into, right? So for reservoir engineering, there are very few common parameters, or let's say key terms, that is associated in the reservoir engineering industry, and which also they serves it serves as the basis for many interviews as well, if I'm not wrong. Yes. Like porosity is one, phi, right? Then permeability, then saturation of fluids, then we have the capillary pressure, then we have the wettability, whether it's oil wet, whether it is a water wet system, right? When it comes to porosity, then again we have lot many porosities. Yes, we have effective porosity, right? We have like we have absolute porosity, right? Then for permeability, again we have lot many permeabilities. We have relative permeabilities, we have absolute permeabilities. Saturation also, we have saturation for oil, water, right? Then for capillary pressure, depending upon the wettability, then again, so lot many things comes up. Yes, so you can see that from one particular term, there are a lot many terms that are coming up. There are a lot many scenarios that are getting, those are arising. So this is what we are looking into it. Yes, and all these parameters which you see, right? So these are all fed into the reservoir model. So finally, the intention of this reservoir model is to ensure that the subsurface is under surveillance as well as it is under a sound management practice. Yes, that means you are keeping a close watch on the reservoir at one end, and also you are managing, you are ensuring that the production schemes are ensured, or let's say the recovery schemes are being implemented efficiently. Yes. So you see now, suppose we are having 3 to 4 wells now. Yes. Yeah. So we have to see that how the fluids will be interacting, how they would be behaving. Yes, when the recovery is to take place. Right. This is one thing that you have to keep in mind, because now we can't decide. Here we can't decide because it's a natural phenomenon. It's a self flow potential of the fluids. So we can just understand. That is what we can do at max. Yes, and that is what is being done at the reservoir engineering labs, especially in the simulation workstations. So you are having some high configuration computer systems, you are having some high configuration workstations. Yes, so that is where people will try to understand, people will get a glimpse that what would be the behavior, what would be the reaction of those fluids when a certain sets of operations or certain sets of conditions are implemented, or it can be implemented. Yes, so we have softwares for this again. Yes, one being the common, that is the Schlumberger's petrol software, right? Then we have CMG, if I'm not wrong. Then again, there are other mathematical simulators. Yes, so a lot many softwares are there, right? Then again, lot many companies might have their own inbuilt platforms by which they can undergo simulation. But out of all, CMG and Schlumberger petrol seems to be the most common choice in the oil and gas industry. But then again, there are a lot many people who are in the mathematical aspects. Yes, but then again, for that you need to have a very sound mind, you need to have patience, because the commercial simulators, although there might be errors, although they might be having certain loopholes, but then again, it is giving you the visual feedback. Yes, whereas the same thing is not expected, the same thing cannot be seen in the mathematical reservoirs, right? So this is how the other roles, or let's say the other departments, are helping, or they are contributing to the reservoir engineering team or to the reservoir engineering department. Yes. Then extending the applications of reservoir engineering, you have the enhanced oil recoveries. Yes, so I think this is very much familiar for you guys, that is the life cycle of the oil and gas operations. So we have the primary recovery, right? So whereby we have the self-flowing potential of the hydrocarbon fluids. Then gradually what happens is, as the pressure starts to deplete, because this is a natural phenomenon which we can't stop, but yes, we can delay it, right? So what will happen is, as the pressure differential, or let's say as the pressure depletion, it starts increasing, or it starts getting dominant, then what will happen is the recovery of the fluids that will also go down, right? So in such cases, what will happen is we would be requiring injection of fluids or injection of displacing agents. Yes. So then what shall happen is we shall be able to receive, or we shall be able to again restore the recovery, if not the full scale as it was earlier, but then again it will be modified, it will be managed up to a certain extent. That means it is favorable, it is profitable. So based on that, what we have is we have three stages of hydrocarbon recovery. So beyond the secondary recovery, now what happens is after secondary recovery, the residual oil, or the oil which is left behind in the reservoirs, they are in such a state that means they won't be able to move on its own. They might be viscous, they might be thick, they might be having heavy molecules, that is heavy hydrocarbon molecules. So now it is not expected that those fluids or those residual oil and gas, means gas definitely will escape because since it's very light, but the residual oil which is there in the reservoirs, so those oils, they have to be broken down, they have to be transformed into a much compatible version of fluids, after which it might be traveling towards the producer well, right? So mostly what we do is we try to improve the characteristics of the residual oil, let's say by uh, introducing temperature. By introducing temperature, what should happen is the viscosity would be brought down. Yes, the density would be brought down in a way, right? Then we shall be having certain fluids, we shall be displacing those fluid fronts, and accordingly to the various recovery stages, what you have is you have the recovery factors, or let's say you have the oil recovery that is targeted at each and every stages, right? So for primary recovery, what you have is you have the natural flowing potential, after which as the natural flowing potential of the oil and gas starts diminishing, then what you do is prior to the starting of injecting injection wells or injecting fluids into the reservoir, what we have is we have the artificial lift. So the artificial lift is the continuation of the natural flow, or let's say it's the continuation of the initial primary recovery. So once the artificial lift mechanisms, like we have the sucker rod pumps, we have the progressive cavity pumps, then we have centrifugal pumps. Yes, so all those pumps, whatever the pumping mechanisms we are using, it can be the gas lifts as well. So when those artificial lifts are also no longer able, or they are not capable enough to retrieve oil to the surface, then what will happen is then we have to take help of another well, that is the injection well or the injector well, to introduce certain fluids or certain agents which shall be displacing the oil towards the, where did it go? Yes, this one. We shall be displacing the oil towards the producer well, right? So that means the issue is as such that oil is existing here, right? But it can move ahead. So that is what the problem is. So we have to displace all the oil, all the residual oil towards the producer, so that we are able to recover it, we are able to produce it at the surface, right? So as we are doing this, then what we do is we prolong the economic limit or the abandonment limit that we are trying to that we are trying to achieve. Yes. So what we have is by the introduction of secondary recovery, we shall be having, or we shall be able to prolong the abandonment phase, or we shall be able to prolong the productivity period. Yes, similarly when we have the enhanced recovery, the same thing happens. Or else, if suppose we have not employed the secondary recovery, we have not employed the enhanced recovery, then what will happen is we will be forced to terminate the production here itself. So you see, although the time is still the same, it might be the same, but what's happening is the production rate, you can see that the recovery is changing variably, right? This is what you're doing. Now the issue, or let's say the science behind the residual oil, is they are being trapped within the reservoir pore network. Yes, so since they are being trapped, we have to free them. And in order to free them, what we can do is either we can lower down the viscosity, or we have to lower down the interfacial tension that is existing between the rock surfaces and the fluids, right? Or let's say between the two fluid systems, since those are the immiscible fluid system that is existing, right? Or let's say the capillary pressures, because since those are pores, so the pores would be exerting capillary pressures. So this trapped fluids has to be set free, and only then what will happen is they shall be able to move towards the producer wells. But then again, just by injecting fluid does not ensure that the fluids would be moving, or let's say the oil would be moving towards the producer or towards the production well. Right? So we have to ensure a sweeping characteristics as well. That is uniform displacement of the residual oil front towards the producer. If not, then what will happen is there will be selective flow of the fluids, and they shall give rise to viscous fingering again. Yeah. So you see, that means you don't require water, but the water was rather injected to displace or to force all the oil bank in the production well, right? But you see that since water is lesser in viscosity than the oil or the crude oil, or let's say the residual oil, so definitely it shall definitely bypass the residual oil, which is viscous in nature, because more the viscosity of the substance is, harder it is for it to move ahead, right? Because the subsequent layers of that particular fluid is itself providing a resistance towards the flow, then it won't be able to move ahead. Okay. So in order to eradicate those problems as well, we need to have certain formulations. Those are chemical formulations. So those chemical formulations will ensure that the fluids are uniformly moving towards the producer well, right? So from the original oil in place, whatever we have estimated, and from there what we had is we have the recoverable reserves. Yes. So those recoverable reserves would be recovered. They would be exhausted. Then what remains is the unrecoverable reserves. Yes, those part of the reserves which were not recoverable at that time. So that becomes the target to implement the enhanced oil recovery, or let's say the improved oil recovery techniques. And then finally what will happen is we end up bringing down the percentage, or we end up bringing down the barrels of oil that was trapped within the reservoirs. So more and more amount of oil is being recovered, more and more beneficial it is for the society, because you know that what is the demand at the current stage. Although the prices have gone up, but then again there's a high demand for the hydrocarbon fuels, right? Then I'll just move over to the unconventional hydrocarbons part, right? So I'll just, because again we might be having some time constraints as well, so I have been informed about that. So again, yeah. So in case of unconventional hydrocarbons, so now what we know is we have the conventional hydrocarbons, we have the conventional reservoirs as well. Yes, that is the oil and gas, or crude oil and natural gas. So in a similar fashion, by the name itself, you can understand that something which is not real, means not real, but something which is not natural, or something which is not normal. So those are the hydrocarbon reserves which are existing in the subsurface, right, which are existing alongside the nature. So the unconventional hydrocarbons, or the unconventional reservoirs, since now there has been a growing demand, yes, then again we have to tap those resources, or else what will happen is they will undergo maturity. And once they undergo maturity, then what will happen is we shall be losing out the products, we shall be losing out the naturally existing hydrocarbon fuels. So now that it's a high time that the industry, that is the various oil and gas companies, they have started tapping the unconventional hydrocarbons as well. But the problems with those unconventional hydrocarbon is that means the amount of investment that a company has to bring up for that project does not bear fruit, or does not get that much of profits at the end. Yes, so that's why governments are coming up, they're coming up with financial incentives, or some kind of fiscal incentives, by which it can be subsidized, and the load burden on the companies would be then reduced. So it will be means it will be a sharing contract, means that, or let's say that would be a sharing approach, whereby if suppose there are laws that are being borne by the company, it shall be borne by the government as well. Why the government? Because the government has to provide those resources to the public, If not to the public, then at least for its own official users, it has to have the resources, right? So that's why it has become a high time that that the companies are being asked to, you know, uh, recover the unconventional hydrocarbons. Now when it comes to unconventional hydrocarbons, you have lot many examples, you have lot many resources, you have lot many options. One being the unconventional gases, which can be the coal bed methane, or most commonly it has been called as CBM. Then you have the natural gas hydrates, then you have the shale gases, right? Then again you have the shale oils, you have oil sands, tar sands. So lot many hydrocarbon potentials are there, but the problem is the output is not favorable enough, as we have seen in the conventional hydrocarbons. But then again, there has been a growing demand, and also there has been a growing interest in those unconventional hydrocarbons. So if tomorrow, if suppose you are to undertake certain dissertation projects, then definitely you can also look for unconventional hydrocarbon topics, right? So in case of the coal bed methane, or let's say CBM most commonly, so the coal bed methane is the methane gases that are trapped within the coal seams or within the coal mines. So earlier what the mining industry used to do is they used to, blast off the coal mines, and then what they used to do is they used to let the methane gases out into the atmosphere, right? But now there is a growing tension of the greenhouse gas emissions, yes, the carbon emissions. So, and again, you know that methane is one of the potential greenhouse gases as well, right? So now means what we are doing is, instead of going with the conventional approach, now what they do is the oil and gas industries, they have started exploring the coal mines where thereby there are coal bed methanes, right? So this methane would be trapped, yes, by drilling some horizontal wells, some directional wells, and then from those coal seams. Why directional and horizontal wells? Because the coal seams or the layers of coal which are existing, they are very much thin, right? So since they're very much thin, so what will happen is we can't drill the conventional wells because it won't be able to reach to a greater extent, right? So that means I'll just show you. So this is the coal formation or the coal layer. So if you just do drill a conventional well, so that is not sufficient. So instead, if you drill a horizontal well, then it is now getting exposed, or now it is now exposed to a larger extension of the coal mine, right? So this is what is happening. So now what happens is, after the well is being drilled, then what we do is we dewater the entire coal mine, or whatever part is being exposed to that particular well. So while dewatering the coal mines, and what happens is we remove the methane. Yes, this methane can be readily used as a natural gas, and then those coal can be then used for the mining purposes, or whatever purpose those coal mines were being, they were being explored for. Yes, that is one. Then what you have is another unconventional hydrocarbon is the gas hydrates. So when you're talking about gas hydrates, so it is the gas molecules that are trapped within the water molecules. But in this case, the water molecules are designed in such a state that they form a cage-like structure. So inside the water molecules, what you have is you have the gases, that is the natural gases, right? So this gas hydrates, when you are receiving or when you are coming across it, so you shall be finding it as a dry ice. So it's a dry white mass that you shall see, and when you just burn it, so it will burn very clearly. This is how it burns, as you can see in this image, right? So these gas hydrates are nothing but gas molecules which are trapped within the water molecules, or let's say within the water cages, which is having a very good potential of providing energy, which is having a very good potential to give you a wide number, or let's say a wide reserves of methane as well, right? So like means we are looking for options, we are looking for sources, means to tap the best possible hydrocarbons, be it in the conventional or be it in the unconventional way, right? So as you can see that this is where the gas hydrates are existing. So as you can say, just by looking at the map, that means hardly there would be any place. Yes, definitely means in this side you're not having any, in this side you're not having any. So that means we need to have again certain operating conditions. Right? So we need to have a low temperature as well as we need to have a high pressure. right? So that is the condition for the existence and for the formation of hydrates again, right? So but then again you can see most commonly it is existing in the coastal areas, yes, in the shorelines. So in these areas the operations are going on according to the color code. You can see that what is going on, whether there is recovery phases, whether there is, you know, some indications or some surveys that are going on, and where the drilling expeditions have already started in order to tap the resources. Then lastly what you have is the shale oil, whereby within the shale rock what you have is you have hydrocarbons, or you have the kerogen means like hydrocarbons which are trapped within the shale oil, right? So the shale rock, then what happens is it is broken. It is broken, and once it is broken, then what happens is we go with some extraction mechanisms or retorting mechanisms, by which the heavy crude oil which is trapped within this shale layer or the shale block, as you can see that this different streaks are there, right? So this will start giving out liquid hydrocarbons to you, right? But the crude oil, or let's say the hydrocarbons which are obtained from shale oil, or let's say from the tar sands or oil sands, so those are too heavy, so those are too viscous. So subsequent processing and, you know, conditioning is required in order to extract the best possible hydrocarbons from them. Okay, so I'll stop it here. So maybe